Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 50 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph here showing the number of stores opened by a coffee company, and we know that it's going to be modeled by an exponential function. All right, so x is your number of years. So let's just make sure we understand what we're looking at when we're dealing with our exponential function here. So y equals a times b to the x power. That is our standard form for the exponential function. And so we've got this a here, and this can mean many different things. So if we're dealing with investments, compound interest, savings account, something like that, it could be your principal, right? That's the amount that you initially deposit. You don't add any to it. You don't take it away. In just more general terms, we're dealing with the starting amount or the initial amount. So whether it be bacterial growth, population change, in this case, we're dealing with coffee stores. But there's always a starting amount. That's going to be your A. And we also know that it's the y-intercept. So we could also view this A term as our y-intercept, because y-intercept is where the graph crosses the y-axis when x equals 0. Look what happens when we make x equals 0. That becomes a times b to the 0. I'm going to replace my x with a 0. Anything to the 0 power is simply 1. So it's a times 1, which is simply a. So when x equals 0, y equals a. So that's helpful. B here is our rate, and so it's going to be a growth rate. If it's greater than 1, it's going to be a decay rate. If it is less than 1, like a fraction or a decimal. Now, our x is going to be our step. Usually it is some type of time frame, days, weeks, months, years. In this case, it is years. They tell us x is the number of years. But it's not always years. It could be a different step. Now, what does that tell us about this graph? Well, we know that we've got an a term of, let's just go ahead and call that 400. Okay? So y equals that 400. We don't know exactly what the rate is, but I don't think we need to know what that is. So we'll just kind of leave it like this, b to the x. But we know that that a is that starting term. So which statement does not appear to be true? Okay, so the coffee company had opened 400 stores by the end of 1992. Well, it says number of years since 1992, and I've got a 400 right there. So yeah, that looks like since 1992, assuming they're counting it at the end of the year, not the beginning of the year, we're counting 1 year since, this looks like that's our initial amount is 400, since that's the y-intercept, which means we're not going to choose it because we're wanting one that does not appear to be true. G. The coffee companies opened 100 stores in 1 year. Well, let's see. 0 years is 400. I'm going to call that year 1 500. And even that year 2 is a little bit more than 600. Right? So it looks like, I'm guessing 625, something like that. So yeah, that looks like between 0 and 1, you do open up 100 in a year. Just 1 year, not every year. Okay? H. Every year the number of stores the coffee company opened increased by 25%. Not too sure about that, because we'd have to calculate some points here. Let's skip that right now. Let's go to J. Since 1992, the coffee company has opened 250 stores each year. Okay, see, that's the problem. You get a percentage increase right here with the B. You don't get a raw number. So obviously we didn't do 250 between 0 and 1. So this one is going to be correct, right? We can calculate from the 400 up to 500 from 0 to 1. That is a 25% increase, right? To 500 to 625. That's also a 25% increase. But even if we didn't know that, this J is incorrect, and that's our answer.